Problems 5 and 6 for AMC 12B 2021 fall. Let's solve them. Problem number 5. It says call a fraction a over b, not necessarily in the simplest form. Special if a and b are positive integers whose sum is 15. How many distinct integers can be written as the sum of two not necessarily different spatial fractions? Okay. Okay, when it says a plus b, a b positive integers, sum of them 15, so the fractions are 1 over 14, 2 over 13, 3 over 12, 4 over 11, 5 over 10, 6 over 9, 7 over 8, 8 over 7, 9 over 6, 10 over 5, 11 over 4, 12 over 3, 13 over 2, and 14 over 1. Now, let's simplify. I want to write the simplest form. 1 over 14, the next one. 2 over 13, the next one. 1 over 4, 4 over 11, 1 over 2, 2 over 3, 7 over 8, 8 over 7, 3 over 2, 2, 11 over 4, 4, 13 over 2, 14 over 1. Okay, when you write in simplest form, if you want, if the sum of two not necessarily different, should be integer. The denominators should be same or similar, we can say. So if we consider 14, we don't have anything similar to that. And this plus itself also is not integer. 13 is not useful. 4, let's see. 4 we have here. We have here. Okay. And for 11, we don't have anything similar to 11. 1 over 2 is good. Second part, it's in second part, all of them. For 3, let's check. We don't have any fraction like 3. For 8, we don't have any 8. For 7, we don't have any 7. Okay, and if you want to learn the reason that why the denominators should be same, you can send message to my WhatsApp number in the comments and description. It's not hard. So 3, maybe also at the end of the solution I will explain. Third part, third part, third. Let me, yes, all of them in. Okay, so in first part we have 1 over 4, 11 over 4. Yes, in second part we have 1 over 2, 3 over 2, 13 over 2. In third part we have 2, we have 4, we have 14. Okay, so if we want to consider 1 over 4 plus even 11 over 4 will be 3. Each of them plus itself is not useful, this one. Each of them plus itself 1, 3, 13. In the first one, 1 plus 3, 4 over 2. 2. Okay, 1 plus 3, 4 over 2. 1 plus 13, 14 over 2, 7. 3 plus 13, 16 over 2, 8. And the next one. 2 plus 2, 4. 4 plus 4, 8. 18, 14 plus 14, 28. 2 plus 4, 6. 2 plus 14, 16. 4 plus 14, 8. Now, let's analyze all the numbers that we can write. 1 is okay, we've written 2. The next one, 3. We don't have 4. Yes, we have 4. We don't have 5. We have 6. We have 7 and 8. And then we have 15, 16, 18, and 28. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 of the things that the problem wants. Let me tell you as a reason why the uh, denominators should be same. Suppose A and B are relatively prime. GCD of A and B is 1. Also GCD of C and D is 1. I want to say if it is integer, then B and D should be equal. So it will be BD, AD plus BC. So here we know that B denominator should divide AD plus BC. So B we know divides BC. You should know divisibility. So if you don't know this sign and divides, you can send message to my WhatsApp number in the description and comments. I explain for you. B divides BC, so if you subtract, B divides AD. Because A and B are relatively prime, we call it Euclid's lemma. You can get rid of A, so B divides A. And similarly, you can prove that, B divides D. You cancel D. B divides B. So B should be plus minus D, so they should be equal. When it is minus of that, it means like minus a positive sign. So here in previous part, because the fractions are positive, so they should be equal. They cannot be negative of each other if it is integer. So it is necessarily condition, not sufficient condition. Okay. So we've solved 5, which is 11. Now let's solve problem number 6. The largest prime factor of 16,384 is 2, because 16,384 is 2 to the 14. What is the sum of the digits of the greatest prime number, that is divisor of 16,383? It will be 2 to the 14 minus 1. And we have a famous identity that a squared minus b squared is a minus b times a plus b. So here, we know it is 2 to the 7 squared minus 1 squared. It will be 2 to the 7 minus 1, 2 to the 7 plus 1. We know 2 to the 7 is 1 to 8, so it will be 1 to 7 times 1 to 9. So the second one, this part, is 3 times 43. And let's check this part. Is it multiple of 3? No. Is it multiple of 5? No. Multiple of 7? Let's check 57. No. Is it multiple of 11? No. We need to only check to 11. Up to square root of this. So it is a prime, and the problem says greatest prime divisor. So, and it wants what? Sum of the digits. So 1 to 7, sum of the digits is what? 1 plus 2 plus 7, which is 3 plus 7, 10. So the answer is C. Okay, if you want to learn other ideas, you can send message to my WhatsApp number in the comments and description. And please don't forget to subscribe, turn on notification, and like the video. Thanks. See you next time. Bye bye.